back, Chapter 9, Section 9.2, Testing the Mean Mu. The focus points in this section. Review the general procedure for testing using p-values. Test mu when sigma is known using the normal distribution. Test mu when sigma is unknown using a student's t distribution. Understand the traditional method of testing that uses critical regions and critical values instead of p-values. Okay. In this section, we continue our study of testing the mean mu. The method we are using is called the p-value method. It was used extensively by the famous statistician R.A. Fisher and is the most popular method of testing in use today. At the end of this section, we present another method of testing called the critical region method or traditional method. The critical region method was used extensively by the statisticians J. Neyman and E. Pearson. In recent years, the use of this method has been declining. It is important to realize that for a fixed, preset level of significance alpha, both methods are logically equivalent. Let's quickly review the basic process of hypothesis testing using p-values. We first state a proposed value for a population parameter in the null hypothesis, H0. So first declare what your H0 is. The alternate hypothesis H1 states alternative values of the parameter, either less than, greater than, or not equal the value proposed in the null hypothesis. We also set the level of significance alpha. What is this level of significance? This is the risk we are willing to take of committing a type 1 error. What is a type 1 error? So alpha is a probability of rejecting H0 when it is in fact true. So that's type 1 error. H0 is true, but you rejected it anyway. All right. So the probability of that happening is called level of significance. Okay. That's the risk we are willing to take. Now, we use a corresponding sample statistic from a simple random sample to challenge the statement made in H0. We convert the sample statistic to a test statistic, which is the corresponding value of the appropriate sampling distribution. We use the sampling distribution of the test statistic and the type of test to compute the p-value of the statistic. Under the assumption that the null hypothesis is true, the p-value is the probability of getting a sample statistic as extreme or more extreme than the observed statistic from our random sample. Okay. So here you are going to compute p-value. All right. Next, we conclude the test. If the p-value is very small, we have evidence to reject H0 and adopt H1. What do we mean by very small? We compare the p-value to the preset level of significance alpha. That is, if the p-value is less than or equal to alpha, then we say that we have evidence to reject H0 and adopt H1. Otherwise, we say that the sample evidence is insufficient to reject H0. The last step, you interpret the results in the context of the application. Knowing the sampling distribution of the sample test statistic is an essential part of the hypothesis testing. Okay, so you need to know the sampling distribution of the sample test statistic. For tests of mu, we use one of the two sampling distributions, x bar, the standard normal distribution, or a student's t distribution. Okay, for x bar, you choose either the standard normal or student's t distribution. The appropriate distribution depends upon our knowledge of the population standard deviation and the nature of x distribution and the sample size. All right. Typically, if you know sigma, you would use standard normal distribution. If you do not know sigma, then you would go for student's t distribution. Okay. Part 1. Testing mu when sigma is known. In most real world situations, sigma, that is the population standard deviation, is simply not known. However, in some cases, a preliminary study or other information can be used to get a realistic and accurate value for sigma. How to test mu when sigma is known? Requirements. Okay, so we are going to test for mu when sigma is known. Let x be a random variable appropriate to your application. Obtain a simple random sample of a fixed size n of x values from which you compute the sample mean x bar. The value of sigma is already known, perhaps from a previous study. If you can assume that x has a normal distribution, then any sample size n will work. If you cannot assume this, then you use a sample size of at least 30. Okay. In the procedure, in the context of application, state the null and alternate hypotheses and set the level of significance alpha. Use your known sigma and the sample size n, the value of x from the sample, and mu from the, this should be x bar, mind you, and mu from the null hypothesis to compute standardized sample test statistic. So Z, you need x bar, okay, the sample mean, minus mu over sigma over square root n. Now, use the standard normal distribution and the type of test, either it is one-tailed or two-tailed, to find the p-value corresponding to the test statistic. Conclude the test. If p-value is less equals alpha, then reject H naught. If p-value is greater than alpha, then do not reject H naught. Interpret your conclusion in the context of the application. Now, we have examined p-value tests for normal distributions with relatively small sample sizes. The next example does not assume a normal distribution but has a large sample size. So they are talking about p-value tests. In our previous section, we worked with a normal distribution where n sample size was less than 30. Okay, but now you don't assume a normal distribution, and you have, therefore you need sample size of at least 30. Okay, so this is example 3, which we will come to in our next video.